Right guys, so today we're going to look at limiting reagents, and the first thing I want to look at is how do we calculate the mass of magnesium bromide when you have 2 grams of magnesium reacting with 5 grams of bromine. Now in this example we have to remember that there's 2 very important principles here. One is an excess amount and one is a limiting amount. Now when something is in excess, we basically are saying that there's lots of it available, all right? Too much that some of it becomes left over. And the limiting reagent in this case would be the one that is going to be used up first. And when we say that, what we're saying in essence is that one is less, i.e. one is going to be used up first and the other one is still going to be left over. And from this type of reaction, we can find out 2 things: the number of moles of both, and then compare which one has an excess amount and which one has a limiting amount. So let's try and use the method whereby we have everything in our question. So I'll just write it again over here: Mg plus Br2 and arrow Mg Br2. The arrow tells us that something is being produced, in this case magnesium bromide, and we have the number of moles, we have mass, we have molecular mass, and we have is it limiting or is it in excess, and that's what we're going to find out. And what I'll also put here, I'll put ratio here because the molar ratio is very important. Now the molar ratio, there is no number in front of these, i.e. the coefficient, so let's just assume that these are all now going to be 1, which I've written in yellow. The number of moles we don't know yet, but we're going to work out from the masses. Now in the question, I've underlined it here, we've got 2 grams of magnesium. So we've got 2 grams of magnesium, and then we've got 5 grams of bromine. So let's work out the number of moles of both of these, and the way you do that, just get a calculator, and we should really know what the MRs of our molecules are, or our atoms. In this case we've got magnesium, which is 24. It's 24.3 if you do A levels because you do it to 1 decimal place, but we're just doing it at GCSE level. So 2 divided by 24, and that gives you an answer of 0.083. So let's write that down over here, 0.083. Now be careful over here because we've got 2 bromines over here. Now bromine has a MR of 80. Just be careful with what kind of numbers you have for your MR. Now I'm doing the AQA periodic table here, so the AQA exam specification might be slightly different to another periodic table from a different exam board. So they might use 2 decimal places or 1 decimal place, so just be mindful. Some of them have the MRs at the top, some of them have the MRs at the bottom, i.e. the atomic mass at the bottom or the atomic mass at the top. So just be mindful of that when you do this type of question. But yeah, back to this. So we've got bromine, which is 80. Now there's 2 lots of bromines over here, so that's going to be 80 multiplied by 2, which gives me 160. And we've got a gram of 5 grams, so that's 5 over 160. If we do that in the calculator, that gives us 5 divided by 160, 0.03125. 0.03125. So we've got the number of moles of both of these. Now, lucky for us, we've got a 1-to-1 molar ratio, so this is nice and easy. Okay, what mass of our magnesium bromide is going to be produced? Well, we've got to take the smallest number of moles, and we're looking at the molar ratio over here because it's a 1-to-1. This is quite easy, and we can see that there is definitely a smaller number of moles over here. 0.03 moles is smaller than 0.083, so we're going to take this one as the limiting reagent because this one is used up first, and this one over here is therefore in excess. So we're going to use this as our number of moles to then scale up for our magnesium bromide. So if I've got 0.03125 moles reacting of bromine here, I've therefore got 0.03125, because it's a 1-to-1 ratio of magnesium bromide. And so the last thing you do then is you do your calculation to work out mass using the formula number of moles equals mass over molecular mass. Rearranging that becomes mass equals number of moles times the MR. And so there you have it. You have to do 0.03125 multiplied by our MR, which we said was 160, plus 24. And that gives me 184. So 184. And so let's do that in the calculator now. So times the answer by 184. And you have an answer of 5.75 grams. So that equals 5.75 grams. And that's your answer. So recap, have your variables on the side, a little bit like a table. We call it the table method. You don't have to actually put a table in there. Some sequential column or structure, and then you can kind of work out what you have and what you don't have, and then go from there. So we've got 5.75 grams. Nice and easy. Now let's look at a more difficult one. Okay, so this time we have iron oxide reacting with aluminium to produce iron and aluminium oxide. So what we have here is basically a displacement reaction where the aluminium is taking place of iron in iron oxide because aluminium is more reactive. Now in this question, again, we're looking at limiting reagents, and so we have to work out from what we already know. So the first thing you need to do is make your variables available. So you've got your number of moles, N, the mass, you have molecular mass, and then you have your excess or limiting, and then you have your molar ratio. I mean, you can have in any order that makes sense to you. I mean, you could have this in front instead of the N first, but it's okay. So the mass that we've got in the question, we've got 8 grams of iron oxide. So iron oxide is this one over here, so we've got 8 grams of that. Reacting with 2.16 grams of aluminium, so that's 2.16 grams of aluminium. Now we've got to find the moles of both of these first of all, so let's do that. So 8 grams divided by Fe2O3, and I've worked it out over here already for you guys, and the MR of that is 160. So 8 divided by 160, now if you do that in the calculator, what do you get? Some of you can see this is quite an even number here, so you can probably do it in your head, which is 0.05 moles, and then we have to do 2.16 divided by aluminium. So 2.16 divided by 27, which is 0.08 moles. Notice that I didn't do 2 lots of aluminium. That's for the molar ratio. So these numbers in front, obviously there's no number over here, so that becomes an imaginary 1. So we know that's going to be 1 mole of iron oxide reacts with 2 moles of aluminium, which gives 2 moles of Fe and 1 mole of aluminium. So that's a 1 to 2 to 2 to 1 relationship. And now it's asking us to work out, so once we've found out the number of moles for both of those, now we've got an interesting situation here because we need to know what's excess and what's limiting. But be careful, because this time we've got 1 mole of iron oxide, so 1 mole of Fe2O3 equals 0.05. Okay, but 2 moles of aluminium equals 0.08 moles. So let's have a fair relationship here and a fair comparison. So we need to find out how much 1 mole of aluminium is first. And 1 mole of aluminium, if we divide it by 2, so divide that by 2 and divide that by 2, and that should give me 0.04 moles. So now we've got a fair comparison. So we've got 1 mole, and I'll circle this in red, 1 mole, or pink, 0.05 for the iron oxide, and then in the other color we have our 0.04. Now from both of these you can see that 0.04 is smaller than the 1 mole of iron oxide. So therefore this is indeed our limiting reaction, our limiting reagent, and this one is in excess. So therefore we've got to take this as our answer. So this one over here is the limiting one. And that's very important not to get that confused. It's very easy to have said that because you see 0.05, you might think that that's the smallest number of moles, or therefore that's the limiting reaction, limiting reagent, sorry. But in fact, when you divide this by 2, because this is showing you 2 mole right now, if you divide it by 2, you get 1 mole, which is 0.04, and that's smaller. Okay, so if I've got 0.04 moles, I've got to then times it by this to find the number of moles of iron, because that's what my question's asking me, the mass of iron. So that becomes 0.08 as well, because 0.04 times 2 is 0.08, or simply 2 to 2 here, and that's the same. So now we're nearly there. We've got to find now the mass by doing molecular mass times our MR. So that becomes 0.08 multiplied by the MR of iron, which is 56, and that should give us an answer for our mass, which is going to be 0.08 times that by 56, 4.48 grams. 4.48 grams. And there you have it. So remember, this part over here is really the tricky part, making sure you know which one is an excess or which one is limiting. Okay, always do a little side check, and if you see that both of them are 1 moles, sometimes it may seem that Fe2O3 is larger, but in fact when you do the molar ratio and work out 1 mole for each, you then find out that actually this was smaller. So this one was limiting over here, and this one was in excess. Alright, thank you for listening.